Awesome. All right. Thank you so much. So I'm really excited to be here with you guys today. Before anything else, if you haven't done it already, please install Docker. So this first one here is where you can find Docker Community Edition. So that's what you're going to install if you have like a more recent version of Mac OS or Linux. And also, if you're on Windows 10 Professional, you can install Docker for Windows. However, if you've had any trouble at all installing this is the link that we sent out. And you can go to the second link here, docs.docker.com/toolbox/overview. Some of you may actually have Docker Toolbox. That was kind of like what came before Docker for Mac and Docker for Windows. So if you're having trouble with the recent version, you can install Docker Toolbox. That'll work on older machines and older operating systems. Also, if you do happen to be on Docker for Windows, then if you could go down inside of the toolbar on the bottom right-hand side of your screen, and if you click on the little Docker icon or right-click on the Docker icon, if you see this option switch to Linux containers, go ahead and switch that now. If you open that up and you see switch to Windows containers, that means you're good. Don't click that. We want to be on Linux containers. I'll explain kind of what that is later on. That'll make sense. But just for now, go ahead and make sure you're on Linux containers so that we're all on the same page and all the examples work. All right, so thank you all for coming today. Thank you, Neha, for having me. I'm really excited to share all this with you guys. So we're going to give a kind of a workshop about Docker and how Docker can help you as a JavaScript developer. Also, before we get started, there'll be 2 repositories you'll need as code examples that we'll use as part of the examples. So you can go to my user profile on GitHub. The 2 repositories you want is Bob is Cool, which is like the coolest app in the world. And the second is New Year's resolutions. Okay, so Bob is Cool, New Year's resolutions. You can find those on my GitHub profile page. My GitHub username is Hayden BR. Okay, we'll have those links later on if you don't get them now. But just go ahead and clone those. All right, so quick agenda. The first hour and a half, we're going to just give a nice intro to Docker. It's going to be completely agnostic of language or framework, so it's just going to be Docker and containers. What is this new stuff that we hear about all the time? And it really won't have anything to do with JavaScript. We'll take our break, and then the second portion will be, okay, how can Docker help us out as JavaScript developers? And so we're going to Dockerize or containerize our JavaScript development environment. And lastly, hopefully we'll not see too many memes and GIFs. If you don't get any of, I don't know, like internet culture in America is a little different than internet culture in India. So if you don't get some of them, just be like, whatever, that crazy American is going off the deep end. A little bit about me. I'm from Richmond, Virginia in the US. It's on the East Coast. We lovingly call our city RVA. I work as a software engineer at Unbox Technology. What we do at Unbox Technology is most of what we do actually doesn't have anything to do with technology. It's a bunch of content writers and animators and video producers. And then we have 2 software teams that work on software products that we developed in-house that fall in the learning and development market. So I work on one of those teams. I do mostly JavaScript, a little bit of .NET here and there. Now, how I got started with Docker was a while back. One weekend I said, you know what, I've got no plans for the weekend. So I said, you know what, I've been hearing about this Docker thing that seems to be really cool these days. So I just kind of like binge watched as many tutorial videos as I could, and then that's kind of all started from there. Then I started, actually using it for real use cases, playing around on the command line to see, how I could push the limits of Docker. And yeah, Docker's a lot of fun. So usually on the weekends, I'm playing with Docker, playing with JavaScript. Yeah, it's fun stuff. And I also love me some South Indian food. I was in Hyderabad last week. Probably one of the best weeks of my life. I ate about a month's worth of food in a week. So let's go ahead and get started, and let's give it a nice intro to Docker. So what is Docker really, right? So we've been hearing about this. Docker's 5 years old now. So what is it? The definition I came up with was Docker is a virtualization technology that allows you to create isolated, minimalistic environments that contain only the absolute necessary dependencies needed for a specific purpose. Right, now that purpose is typically running an app, running some kind of service, or running some tasks inside of this environment, okay? So what we do with Docker is we create environments which we call containers, and those run either on our local machine or on a server somewhere, and those are used to run apps, right? So the apps that we run inside of containers are isolated from the outside environment of the host machine on which they live. So that's Docker as a technology. Docker is not the only platform out there that you can use for containers, but Docker was one of the major forerunners in the containerization technology. We're starting to see, since Docker was first released 5 years back, the idea of containers, whether it be Docker or similar tools, is really starting to catch on. Docker is also a company, and they also have professional services. They have an enterprise edition of their containerization platform as well. Now, why should you learn Docker? We'll go into a couple reasons of why we should, but first reason, I saw this on Twitter recently. So Gartner predicts that by 2020, more than 50% of global organizations will be running containerized applications in production, which is up less than 20% from today. So even as developers, Docker and containers have the biggest impact for DevOps people, but even for developers as well. If this is the way that technology is going towards, if we're kind of moving in this direction, even if we're not DevOps people who are responsible for getting that code into production, we should at least be familiar with what's going on behind the scenes. And even if you're not in DevOps, there's plenty of use cases for Docker, even in development, right? So the second portion of today is just going to be using Docker in development. And the great thing about Docker and containers is that, maybe you want to start catching on to this new stuff. Well, you can start using Docker in development, and then after a certain period of time, you can very slowly move from development and then start getting things into production over a long period of time. And one of the great things about containers is that it kind of brings devs and ops much closer together, right? So when you're running your applications in development, which is what we're going to do today, you can create an environment that's much, much closer to the actual production environment that it would be running in. So that's one of the great uses for Docker. Docker is really disrupting the norm. So as we see by 2020, if 50% of applications in production are running in Docker containers or some similar technology, that's a huge shift. So let's see, it's 2018, Docker came out 5 years back. So from 2013 to 2020, if 50% of production applications are using containers, that's a really fast shift. It's a really fast change from how things are done today. So at the very least, it's nice to know what's going on and to be able to catch up. So as I mentioned, some typical use cases are running apps in production. You can maybe use containers to build microservice applications. But at the same time, there's also some more atypical use cases. So for example, I was talking to a guy Saturday, and he had a free version of, or like a trial version of the IntelliJ IDE that only lasted 30 days. So he would he was able to run the IDE from a container, and then every 30 days when the trial ran out, he just restarted, and it was all good. So there's also very atypical use cases. I've seen people really smart people who've been able to pretty much run their entire desktop from containers, which is not something you would do, but it's fun, you can do it. So Docker is great for portability, right? So the saying, works on my machine, right? So Docker really helps us fix that problem, because if it works on your machine in the environment inside of the Docker container, then it should ideally and much more consistently work on anyone else's machine or server that has that same environment set up. It also helps with agility. It's much quicker to go from dev to deployment. And also in production, it's much easier to scale up, scale down. If there's some issues, there's tools out there that can help you keep a certain amount of containers going, and all kinds of crazy stuff you can do really, really fast to keep your production environment optimal. And also it's much more efficient. So as we'll see, using containers to run your applications is a much more efficient use of computing resources than how things were done traditionally, how things are done now. In the old days, speaking on efficiency, like way back when all of us were children or before we were born, applications were run, you would have one application per physical server. There's no way that one application is going to take up all that space. And so there's a lot of wasted computing resources, there's a lot of wasted time and money trying to maintain all those servers. And it's just a big money hole, right? It was a waste of money, waste of computing resources. At some point, they came up with virtual machines. these days, more often than not, our production applications run in a virtual machine, whether that's a virtual machine on our own servers or a virtual machine on the cloud somewhere. It's how it's done, right? So instead of only using a small portion of the computing resources of a server, you could just max out the capabilities of that server, right? So if you needed a new application, you just find a server that has some available space, create a new VM with your operating system, and run your app. So it was much more efficient than just one server per application, but even still there are problems with that, right? Because you had to have multiple virtual machines, and you have to partition your machine for each VM, and that is a costly operation. It takes time. You have to have a whole new operating system for each virtual machine, and just even forgetting about the app, just running that OS itself was a lot of overhead. There was a lot of background processes going on just to maintain the OS itself, and it's wasteful. But that's how we do things these days. So how does it go with Docker? With Docker, how we can do things instead is for that one server, you'd have just one operating system. And then on top of that operating system, you could run as many containers as you wanted to. So a container is these lightweight environments, these virtual environments that we were talking about. And the server itself that you're running your code on, the server might be it might be a physical machine that you have yourself, or it might be a VM, like your server down here might be a VM itself on the cloud somewhere, and then you're running multiple containers from that virtual machine in the cloud. But only having one operating system is much more efficient, and then the rest of the free resources can just be used for running the things that we care about, just running our applications. Additionally, it really helps with isolating, right? So inside of our containers here, all these are isolated. So you might have 4 or hundreds of containers running, and each of those containers have no idea about the other containers that are also running. It only knows about itself and what's happening inside of itself, and it doesn't really even know. It knows very little even about the host itself. So it's a great way for keeping everything isolated. And additionally, if you have your own server or VM, you've got to take care of OS updates, and of course, you do still have to take care of some maintenance on this level here. But if you have, maybe a language version needs to update inside your container, instead of having to do maybe some security updates, if you can do that at the application level, then all you need to do is just create a new container, update the container, which is super, super quick operation, rather than having downtime to take care of your OS, take care of your virtual machine. So all around, it's just much quicker. It's a much nicer experience, and there's a lot less waste. And also, just for future reference, when I refer to the host or the Docker host, we're talking about the machine that the container is running on. So in our examples, the computers that we're using, these are the host for our examples. All right. Now, how does a container compare to a virtual machine? A virtual machine partitions physical computing resources on the container, on the host itself. So I'm going to get all mixed up with all these different words, so forgive me. While a container only partitions operating system resources, right? So when I first heard of Docker, I was like, all right, so explain to me, what is this Docker thing? And someone told me, and you hear this pretty often, that Docker or Docker containers are kind of like a lightweight virtual machine. And I mean, like, that kind of makes sense. That's kind of an easy way to first understand it. But in reality, truly, a container is more like a virtual operating system, because all of the computing resources are available to a container. Now, you can set limits. Okay, each container can only take so much. This container can have this container can have that. You can set those limits, but by default, a container or all containers share all of the computing resources. So instead of having to allocate beforehand, okay, this virtual machine gets this and only this, we can much more dynamically allocate our computing and system resources. All right, so where did Docker come from? So Docker started as an internal project at this company called .cloud. So people would give .cloud their applications, then .cloud would run their applications on AWS. And so they had kind of like this secret sauce going on, and people started getting curious. Okay, what are they doing under the hood? What are they doing behind the scenes? So as more and more people were asking, they said, you know what, this is really where it's at. Instead of our service, it's our software. So .cloud changed from Docker Inc. And the initial release of Docker as a software was on the 13th of March in 2013. So it's almost 5 years old. And it was built originally on Linux containers. So containers, the idea of containers have been around for a little bit. So it was originally built on the Linux native implementation of containers and AUFS, which is a union file system. Since then, it's been updated so it doesn't have the dependency on Linux containers, so it's much more stable these days. Also, I'm going to throw it out there. If you get a chance, there's a 5-minute video you can find on YouTube where Solomon Hykes, the current CEO of Docker, when he did like a 5-minute lightning talk on Docker and at a conference. And that's such a cool video because in 5 minutes, he introduces what is Docker and kind of a preview of what you can do to use it. So that's a great thing that you should check out on your own at a later point in time. Now, I'm saying, okay, Docker a lot, I'm talking really high level. So at this point, you're probably curious, okay, but what is Docker really, right? Because we're talking at a very high level, so let's see some details. We're gonna now talk about containers and images, which are kind of like the two major pillars of Docker containers, of Docker containers and images. And then we're gonna talk about this thing called Docker Hub, which is a place on the internet where you can get other people's images that they've built and use them, kind of like GitHub. And then we're going to talk about the Docker engine, which is kind of a behind-the-scenes look of what's happening on your computer while you're running Docker. And then we're going to spend a good amount of time getting our hands dirty and just playing with Docker, working through a few examples on your command line. So what is a container? As I mentioned, a container is kind of like a virtual OS. So someone asked a few minutes back, okay, are containers independent of the underlying operating system? So no, they're not independent. They are dependent on the OS of the host machine. A container has to share the host kernel, right? So if you remember when we started, I said, okay, if you're on a Windows machine, go ahead and switch over to Linux containers from Windows containers. So yes, they are dependent on they share the kernel of the host operating system, because a container really is just an abstraction of kernel primitives. Okay, so for example, in Linux we use two things called namespaces and control groups, or usually shortened C groups. And these two native primitives of Linux are what are being used to create your containers. Okay, so originally you could only use Docker on Linux. Okay, but then they came out with this version called Docker Toolbox that you could install on Mac and Windows. And that would have, I think it used VirtualBox. It would install a very thin, lightweight Linux VM on your machine. So you're still running Linux containers on your Mac or Windows machine. These days, Windows has added some things to their OS kernel that can support native Windows containers. So before, if you wanted to run something like IIS, or like an older .NET application, you still couldn't really do that in containers because you can't use those things on Linux. Although they did recently release those things in Linux, I think. I don't know. I'm not a Windows person. But nowadays, there is a such thing as native Windows containers. So on a Windows machine, if you have Docker for Windows installed, and you're using Windows containers, then when you create a container, it's using native primitives of the Windows OS to actually create those containers for you. So does that answer your question? You asked that, right? You asked that? Yeah, does that answer the question of OS dependent? Okay, cool. As I mentioned, each container gets its own file system, its own process tree, its own network stack. So all that is isolated from other containers and from the host itself. So what is an image? So an image describes what a container should look like. It describes the file system and any installed dependencies inside of inside the container when you run it. Now, in traditional operating systems, like you have what's called the OS system image, which is like a file that describes the entire state of the operating system. So in a very similar way, in Docker land, an image is pretty much the equivalent of a system image in traditional operating system land. Or similar, if you use AWS, you have like an AMI, like an Amazon or AWS machine image, which is what you use to start a new VM. Very similar way, image kind of does the same thing for starting containers in Docker. When you first learn Docker, it's kind of hard to keep straight. Okay, where do we draw the line between an image and a container? So you can kind of think as containers as like an instance of an image. So you use an image to start a container, and inside of the container is where your applications are run, and the image was just the starting point. Another way of looking at it is that a container is a runtime construct, while an image is a build time construct. So the code actually runs in containers. We build containers from images. Images are more static. And also when we build images, which we'll do today, we build them from a special file, which is a special syntax called a Docker file. Now, it's important to note that an image is read-only, while a container, you can both read and write inside of a container. So actually what happens is each image itself is comprised of read-only layers, right? So an image has all these different layers that kind of build up the file system, that build up the environment that your container will have when it runs. So we can only read these layers down here of the image itself. Now, when you create containers, what happens is Docker will throw on top of all those layers a special read-write layer, okay? And so any changes that you make inside of the container is persisted to this read-write layer, okay? But the really cool thing about Docker is that it uses this kind of union file system, as it's called. So when you create a container, it kind of almost like mashes all these layers together. And so all the containers, so if you have multiple containers based on, like, let's say an Ubuntu image, for example, they all share the same read-only image layers, but any changes they make are persisted at this level so that the integrity of the image itself is maintained, but then they can do whatever they want. It's this special thing called copy on write. So for example, and we'll look at how this works in a bit, but maybe I changed some file, add a file to some directory in the file system that was defined in the image itself. Well, that is copied to this read-write layer, and then all future changes to those copied files and directories are made in here instead of on this level. So it's pretty cool stuff. Also, having these images helps us when we need to rebuild images or build a new version of a previous image, because as we'll see, if maybe the first half of the layers of the image are already built, well then when we go to rebuild that image, we don't need to rebuild those layers, we just build the new layers. So it makes building new and updated images really, really quick. And again, we will see that in our examples.
It helps in caching also.
Yeah, so like those layers are cached, right? So when you build, it doesn't need to rebuild those. It just sees, okay, well, I've already built that. Yeah. All right, so real quickly, let's look at Docker Hub. Hub.docker.com, you can go there on your own computer. So Docker Hub, as I mentioned, it's kind of like the GitHub for images. So on Docker Hub, you will find different repositories. You can create your own repositories. And a repository is meant to contain images of a certain type. So let's search, for example, actually, you know what, I'll go ahead and point this out. So we have official repositories, as they're called, and then we have just user non-official repositories. So my username is HaydenVR on Docker Hub. So all of my repositories that I create are going to be prefixed with my name, my username, and then the name of the image itself. So let's look at some official images, because those are going to be really important for what we're doing. So we'll look at the Node.js official image. It's just the name itself. There's no prefix to it, so that signifies, okay, it's official. Now, an image can have multiple tags, which is essentially like different versions of the image. So we have all these 9.7, 9.7.1. So we pretty much have all these different tags or all these different versions of the Node.js image. And again, so it's almost like, if you're writing some package for NPM, it's going to have different versions. People can install different versions. Or actually, really, it's pretty much equivalent or synonymous to a tag in a Git repository. You can check out different tags. In this case, you can download and use different tags of the repository. So just different version of the image. Some will be much smaller, some will be large. But yeah, and I mean, tagging is kind of arbitrary. So like different repositories are going to tag in a way that makes sense to them. So if you want to use Node.js or maybe you want to use a WordPress image or whatever it is you want to use, you just have to know their tagging scheme. There is a such thing as a latest tag. So if you upload or pull an image without specifying a tag, which we will see, it automatically pulls what's called the latest version, the latest tag. So using the latest version of an image is great for just kind of getting used to Docker and kind of working with some examples. But if you constantly pull the latest version or the latest tagged image, you're not always going to get the same thing. So when it actually comes to building out your dev environment that you want to be nice and consistent, or running applications in production that you want to be consistent, you don't actually want to use the latest tag. But latest tag is just kind of a convenience for getting up and running, kind of getting a feel for Docker on your own machine. There's also this thing called Docker Store, which we won't look at. Docker Store is like, okay, you can find, maybe you have like some licensed software, like some crazy IBM stuff. I don't know. I don't really know anything about IBM. I just know they have like all these like licensed, super expensive enterprise products. So you can find images for those kind of things on Docker Store. You can also find plugins and different things. I'm not going to talk about Docker Store today because depending on your use case, you might not hardly ever even use it. If you're only using like open source stuff, then Docker Hub is where you want to be. But Docker Store is out there. It exists. So you know. Last thing I want to talk about before we actually get into some examples is the Docker engine, as it's called, right? This is kind of a very high-level diagram of what's happening behind the scenes when you run a Docker container. The Docker engine refers to kind of like the client and this daemon process that's running for Docker itself, and kind of these lower level processes that are happening to make containers work. So all this together is kind of known as the Docker engine. So no matter what OS you're running Docker on, you're going to have the client and the daemon, and so interacting with those is the same no matter where you are. So the Docker is built in such a way that's super modular. So you have the same development experience using these two guys up here no matter where you are. And then there's specifications for the lower level parts so that, the specification can be implemented for Windows, it can be implemented for Linux. And so that way you have the same experience up here even though the internals under the hood are different. So this is actually in particular what it might look like for a Linux host. So the client and the daemon, they communicate over a REST API. And then you have this thing called containerd, which is the runtime for containers. It's responsible for creating containers, stopping containers, all the different lifecycle events, and kind of doing and kind of overseeing all of the low-level work to make containers happen. You could use Docker for the rest of your life and not actually have to know the internals of how containerd or any other container runtime works, because all you're interacting with is this. It's nice to know what this does, but you don't have to. And knowing these details is far beyond entry level. So don't be concerned, we won't talk about it today. Then so the daemon and the container runtime communicate over a gRPC API. So gRPC is kind of like an alternative to traditional XML-based HTTP requests. So Google's kind of looking at this. This is kind of a newer thing, but Docker uses it. Might be worth looking into on your own time at some point. And then there's this thing called runc, which is kind of like the last level of defense before you hit the OS kernel primitives that actually create the container, give it to containerd, and then allow you to start using the container itself. So the container is actually way down here. This is like OS level, but when we're working with the container, we're abstracted quite far from those details. So we don't actually, as Docker users, don't have to be concerned about all this low-level stuff and how it's implemented. So as I said, this is how it kind of looks like on Linux. Windows has a similar thing. So down here on Linux, we use, as I mentioned, namespaces and C groups. And then Windows has namespaces and job objects, as they're called. So namespaces are what allow you to kind of create this isolated file system, isolated environment. And then C groups help you control or allow you to control computing resources. Okay, so C groups do that for Linux. Job objects do that for Windows. Now, up until this point, I've mentioned a lot about Linux and Windows containers. So you might be wondering, well, how does Docker work on a Mac? So on a Mac, actually what's happening is there's a thin Linux VM on your machine. Since no one actually, runs, production applications in Mac, we probably won't ever see like native Mac containers. Yeah, we'll probably always be using Linux containers on a Mac. So yeah, that is what it is. All right, with that being said, it's time for some demos. Let's get our hands dirty. Any questions? Yes, sir.
You can actually make if your application generates logs, right?
Yeah.
And so what is the best way to retain those logs after the container is destroyed?
Yeah. So if you want to have logs after a container is stopped and not destroyed, you can still easily access those logs. If you want to retain logs after the container is destroyed, then you'll need to, create some way of logging that to something external to the container. You're not, and we'll look at this further in a bit, but it's not ideal, and you're actually not supposed to persist data in containers. So if there's something important that needs to last longer than the life of the container itself, then it needs to end up somewhere else, whether it's on the host or some other server somewhere else. If it's inside of the container, it's disposable. All right, so with that, let's go ahead and jump into some examples. Everyone can see this well enough, I suppose. Awesome. Okay, so the very first thing we'll do is we'll run Docker version to make sure everything is working well. So if you run Docker version, you'll see something like this. It shows you, okay, kind of the version for the client, version for the server, which is your Docker daemon running on your machine. We should see this guy right here, which means, okay, we're using Linux containers. So that's Docker version, super simple stuff. Let's do something a little more valuable. Since we're programming and we're learning something new, we have to start with the obligatory Hello World example. But it'll go fast, it's not too painful. Sorry if you don't like Hello World. All right, so Docker container run. So this simple command, oh dang it, there's something in the way there on the screen. So Docker container run is the command we use to start up a new container. And so there's lots of options you can pass to the run command, which we'll see in a minute. But the only other necessary argument you have to give this command is an image. So the name of the image we'll give it is hello world. So we're going to type this and this only. And then we'll see that much. Prints out some text, and that's it. So if you're running this for the first time on your machine, it might actually take a minute, because what's got to happen is the Docker daemon looks to see, okay, do I have this hello world image locally? If not, then it'll go out and it'll check Docker Hub, and then it'll pull down the hello world image from Docker Hub itself. And then once it gets the image, then it runs the container, and then it spits out some text, and the container dies. And so you can read this later on your own if you want, but this pretty much just explains what I just talked about, what kind of is going on behind the scenes when you run a new container. So let's do something a little more significant. So we will do Docker container run. You can name your containers. So I'm going to name this guy Ubuntu. We'll call it my Ubuntu. And now I'm also going to pass the I flag and the T flag. And then for the image, I'm going to say Ubuntu. So these, name, it's pretty self-explanatory. I get to name a container. And then the I and the T flags, what they do, it's normally just shortened as -it, but you can separate them if you want for verbosity. But what they do is it gives you, passes all of, the I kind of passes all the standard input to your current running shell. And then T is what gives you kind of like a pseudo shell inside of the container. So we're going to run this and see what happens. Oh, whoops. I already have one called that. Sorry. I'll give it a name. I'll call it Hayden's Ubuntu. Yeah, so container names have to be unique. All right, so I did that, and boom, all of a sudden, you saw how quick that was. I'm inside of my container already. Again, if you do that for the first time on your machine, it's got to pull the Ubuntu image first, and then it'll create the container once the image has been pulled down. So if we look inside, oh, that's terrible. So you can't see. Let me highlight this. So I just did a simple list command, and so I have an Ubuntu-like file system set up. Now, this isn't a true Ubuntu OS, because if we look at the processes running behind the scenes, all that I've got going on is bash and then PS itself. So we only have, under normal circumstances, you only have one process running inside of your container. And that's one of the main things that make containers so much more efficient. If you run the PS command inside of a true Ubuntu distribution, then you're going to see all the different processes running behind the scenes to make it work. All right. So now I can do whatever I would want to do inside of an Ubuntu distribution. So I'm actually going to exit out of this container. And if I want to see any containers that I have running, I can say, or any containers that I can say docker container ls. And that shows you any running containers. The only one I have right now is actually the slides. The slides are running from inside of the container. Now, I actually just previously started these other two containers, so very similar to showing like hidden files in your file system. I can also do docker container ls-a, and that'll give me all the containers that I have stopped, which is a lot. As you can see, I play with Docker a lot, so there's a lot of stuff in here. But if you have a fresh install of Docker, you'll just see hello world, you'll see the Ubuntu image, and that's it. A quick mention of container naming. So if you don't give containers a name, they get a default name, which is just a randomly selected adjective and a randomly selected name of a well-known mathematician or computer scientist. So in this case, Agitated Lovelace is the name of this container here. But then here's my Ubuntu. That's the name I gave it. Didn't get that weird default name. But it's kind of fun to see what names show up. So I typically don't name my containers when I'm on my computer. All right. Also to note, if you've used Docker previously, you may be more familiar with Docker PS. Docker PS does the exact same thing as Docker container ls. But recently, Docker was like, hey, we've got tons of objects that we have to manage inside of our CLI. So we've got containers, we have images, we have volumes, we have networks, we have services, stacks, swarms, all kind of other stuff that we won't look at today. And so before, all of the container commands weren't prefixed with container, but then they said, okay, let's prefix container commands with container so the user actually knows what's going on. So if you're familiar with Docker PS, you can still use that, but I'm going to do my best to use the more updated version for clarity. All right, the next thing we'll get a little more advanced. All right, I'm going to clear this out. So now let's do something a little more significant than just hello world in Ubuntu. So now we're going to do docker container run. And again, we're going to do the int flag so we can see what's going on. And now this time, actually, and let's give it a name. We're actually going to create an Nginx container. If you're not familiar with Nginx, it's a web server kind of like Apache. So we'll say Nginx server, and then the new thing we're going to do here is publish. So what publish does is it channels any network traffic on a certain port from the host into a specified port inside of the container itself. So since Nginx is a web server, it's listening on port 80. But if it's listening inside of port 80 itself, I've got to have some way of hooking a hole, if you will, inside this container to get network traffic from the host inside the container. If I don't do this publish step, then that's fine. The process inside of the container will be listening on port 80, but nothing will be able to connect to it from the outside. So we'll say publish, and the syntax is pretty simple. You just say whatever port you want on your host machine, and then the port inside the container. And then lastly, nginx is the name of the image. I'm hoping I don't already have a container with this name. We'll see. Doesn't like that, so I must already have. You know, I'm just not going to give it a name. I'll get rid of the name. All right. Oh, you know what? It's the container is running. So if I can, let me get a browser window over here. So if I go to localhost 8080, then I'm connecting to that container. So it channeled network traffic from port 8080 on the host machine to port 80 inside of the container. Now, to know about port 80, I'd have to be familiar with, okay, how the image was built. So in that case, I would need to look at the Docker file. And the Docker file, as we'll see in a few minutes, specifies which container ports we're exposing to the outside world. But as far as on the left-hand side, geez, I can't even see my cursor. Oh, here's my cursor. On the left-hand side, we give whatever port we want on the host, and then the right-hand side is the port inside the container itself. The one on the left-hand side is arbitrary. You can pick just any unused port on your host. It was asked towards the beginning, okay, can you have multiple containers listening on the same host? You can in a way. You can use services, which you create using a tool called Docker Swarm. So there are ways to kind of have higher levels of abstraction where we have multiple containers, and then there's kind of like a thin intermediary that Docker will put in for us that's all listening on the same host, and then kind of load balancing between multiple containers of the same type. So multiple containers of the same type, you can use Docker to have them all listen onto the same port. Multiple containers of a different type, you can't, because then every time you requested or every time you hit that port, you would have a different result. So you can't do that. Any questions about what we've done so far?
Which process is actually running inside the nginx right now?
So by default, the nginx image specifies a default process to run. So I don't remember the name of the process, but it's just running its web server process to listen on port 80. All right. Any questions about that so far? We're all good. There should be logging output here, but I think changing the colors of my terminal, some of my words are messed up. Okay, cool. Yeah, so you probably see logging on your computer. Anytime you make a request, it logs a new line here. With that, so I'm actually going to, I'm going to exit out of here. Let's see, I can say Docker ls, what was that? Nope. Docker container ls-a, nope. All right, so the name of that, what was the name? So we get the name of that container that we just created, in this case, which was a wonderful Montalcini. Don't know how to say that. So I can actually, after the container's been stopped, I can say Docker container logs, and then give it the name or an ID of the container. And then I can see all the logs of the container, which I can't see here because of my colors, but you can see. Also, if the container is still running, you can do this cool thing where you can give it a -f command, and it'll bind the output of the logs to your terminal itself. So you'll just see continuous feed of the logs that are coming as they come from the container. All right. So let me make some space. Okay, I can also do some similar things. So let's see, I can say, do I have anything running? Okay, good, only my slides. So I had this container that I called nginx server. So we can do some other operations with containers. So this container's been stopped. So I can say Docker container start, and then nginx server. That restarts a container that's been exited, and then let's see if that worked. Yeah, okay. So I restarted a container that had previously been exited, and then again, I can go to localhost 8080. So let's see, Docker container ls. So here we have, geez, I wish I could see my cursor. I'll fix my cursor during the break so I can actually see it. So here we have Nginx server. So I can say docker stop Nginx server. And then when I go over here to refresh, that connection is no longer active because the container has been killed. So that quickly I can very easily start and stop containers. Last thing I want to do with this container just to clean up is I want to say docker container remove Nginx server, and then now container's gone. It's as if it never existed. And in this case, if you would want the logs, you would have had to, send them to a database somewhere or save them in a file on the host itself. All right, so that's kind of the basics of containers. We'll see more about containers in a few minutes. But before we move on to images, are there any questions about what we did here with containers? Oh, pretty simple. Okay, cool. All right, on to images. So building images is one of the main disciplines that you have to grasp when learning Docker. Typically no matter what you do, it's going to involve writing an image at some point in time. So as I mentioned, an image is built with a special file called a Docker file, and you always have to start with a base image itself. Actually, you know what? Let me go over to my slides for a second. We're about to do an example, which is here. I give you this link at the beginning. So if you haven't gone there and gotten the code yet, go ahead and get it now. So as we'll see, an image always starts with a base image. You can build images just from scratch, but that's not always as practical of a use case. And that's much beyond what we'll do for today's purposes. Now, I mentioned layers. Okay, there's these image layers. So every line or command of the Docker file creates a new Docker image. So typical use cases, we want to have as few lines as possible. And the fewer the lines, the smaller the Docker image. But as this guy mentioned, having everything on one line can cause problems, but we'll see that in a bit. Also, a great tip is if you want to get good at writing images, it's great to kind of see how the people do it. So you can look at the Docker file of some of these official repositories. Docker has designated these people that they call Docker captains, which are kind of like super Docker users who don't work for Docker, but are like kind of community leaders who have been recognized by Docker as great resources of knowledge, whether they're meetup organizers for Docker, or they do a lot of writing on Docker, or they've developed tools to work with Docker, or have produced training courses. These people are called Docker captains, and so looking at their Docker files is a great exercise to learn how to write better Docker files. So we're going to go ahead and start looking at our first Docker file. So I'm inside here, inside Bob is cool.
Do you recommend some of the Docker captains?
Yeah, so actually I think the two Docker captains that I've learned most from, one, his name is Nigel Poulton, the other is Brett Fisher. Brett Fisher is also a fellow Virginian. All right, so we're inside Bob is cool. Bob is cool is just a simple, stupid, do-nothing Angular application. But we're going to build a Docker file so we can have an image to run our stupid, do-nothing Angular application. So from the very first, our first line in any Docker file is always from. It's a special from word. Now, Docker file, it's no programming language. It's just its special set of syntax rules that the Docker daemon will use to build the image. So from, we'll always start with our base. In this case, we're going to start with Node 8.9.4. As I mentioned, it's best to give it a version. If I just say from Node, it'll automatically do latest, but I don't want that. So we're going to use 8.9.4. Okay, so that's the first one. If I can go ahead and build this image from this Docker file. All that will do is pretty much just give me a Node 8.9.4 container. But I could build it from now if I wanted to, but that's not very significant. So we'll move on. Next thing I'm going to do is I'm going to say run, and I want to make a directory called opt/app. So this special run command here, that's saying, okay, I want to run this process inside the image to maybe install something, change something in the file system. Now, when images are actually being built, each layer is built with an intermediary container. So really under the hood what's happening is this command right here is being run inside the container that's used to build this layer of the image. Okay?
So is this directly going to be created inside this image, or is it going to be written in my host?
This will be inside the image. Yeah. Yeah. All right. So that's run. Run is pretty simple. Run is used for pretty much anything that you would do yourself inside of your command line that you would want done inside the image to build the image. Next thing, there's this special command called work directory. If you notice, I've got this like auto completion. So I use VS Code. It has really great language support for Docker. I would suggest you installing that plugin. You don't have to go. All right, so I'm going to set my work directory as this directory I just created. So what that does is that says, okay, once we stick you inside of your container, font size, yes sir. Yeah, sorry about that, you guys in the back. We'll make it humongous. There we go. Is that good? Awesome. Okay, so that says, okay, I want to set my current working directory as /opt/app when my container starts. And this also applies for any future commands that I give or that I put in my Docker file. All right, just for fun, actually, let's go ahead and build this, what we have so far. So I'll say Docker build, I'll tag it as Bob is cool, and this right here. So this command right here is going to build the image for me based on that Docker file. So by default, I didn't tell the command anything about the Docker file that I want to use, but it's best practice to put your Docker file at the root level of your project. And then when I just run this command looks for a Docker file in the current working directory. So right here, the T flag, or I think I can also do tag, but I'll just do T for today. I'm tagging, so I'm naming the image. So I'm actually going to prefix this with Hayden VR since that's my Docker Hub repository username. And then I can also give an additional tag. I can call it latest, or I can call it Delhi, since that's where we are today. The last thing, this little dot, this is the last argument that you give to Docker, to the build command. This right here specifies what we call the build context. So whenever you build a Docker image, you have to give Docker access to read part of your local file system on the host machine. So all this does is says, okay, hey Docker, when you build this image, I'll let you read from my current working directory, because my current working directory might have some files and directories that actually need to be copied from my host into the Docker image itself. I mean, I could specify, maybe I had a special, maybe I only wanted to look at the source directory. I could do that, but I'll just do this for now. So we'll build that, and then we see, okay, it's passing the build context, so pretty much it's passing all of the files in my current working directory to the Docker daemon. That took kind of a long time. And so as we saw here, I always enjoy reading this output. So what we have was the very first step, node 8.9.4, and then it says, okay, running in for my next make directory command, it says running in, and then that's the actually ID, that intermediary container it's using to build that image layer, okay? So, and then again, same thing, there's another layer of the image for this other command. So 3 steps here, we had 3 lines, 3 separate commands in the Docker file. So we end up with 3 layers for our image. And it ends up like this. So if I just go ahead and run, I'll say Docker run -it, Eden BR, Bob is cool, Delhi. All right, now my base image was a Node.js image, which is actually built on top of a Debian image itself. So I'll end up, actually I'll say bash. So I'll end up in here with the bash process running inside of the container. All right, and as you can see, my current working directory is opt/app, as I specified in the Docker file, which is pretty cool. If I went to, I can go up and see all the stuff at the root level. I'll go ahead and exit that for now. So let's go back over to our Docker file. So the next thing I want to do is inside of your Docker image, you can also set environment variables. So we can say, okay, environment Just like if you're in like a Unix system, you can like export environment variables. Same thing you do here. So you just say, okay, environment, and then give it a key value pair. So I'll set my node environment as development. All right, which is the default environment, or the default environment, but do it for the sake of example. Next, I want to start pulling files from my file system and saving them inside the image. So next, I'm going to say copy, and I want to take package.json from my build context, and I want to save that as package.json inside the current working directory of my image. I'll do the same thing with my yarn lock file. I started using yarn a few months back instead of npm. As a side note, I would suggest making the switch as well because it's much faster, and it's like a super easy change from npm. Now, there's also another similar command that's add. It does the exact same thing as copy, so it can copy files from your file system, but it can also like pull resources from like a remote, maybe like a GitHub repository. You can install those files for you, where copy simply only gets stuff from build context, puts inside the image. I could use add here, but if I don't need the superpowers of add, I'll just use copy. All right, next thing. All right, so the next logical step is I've got my package.json, I've got my lock file. I want to be able to run an Angular application inside of my container, so I probably need to install some dependencies. So I'm going to simply run yarn, or yarn install if you want to be a little more verbose. And then this layer is going to be a super huge layer, because this layer is going to be responsible for getting my node modules. Last thing we'll do is I just want to copy some other like config files from my build context that I need to run my application. So I'll copy tsconfig over. I'll copy over tslint. I will now copy over, let's see, .angular cli.json, and last thing, I'll copy over my source files. Okay, I'll give you a minute to finish that if you need to finish it. Now, this right here isn't always what you want to do, copying in like these config and copying in the source. There's times where you want to copy in the source and times where maybe not. And in the second portion of today, we actually will skip this part, but we'll go into the details of that later. Now, I know that my Angular developer server is running on port 4200, so we'll say, okay, expose 4200. And now this right here is the part of the Docker file that says, okay, containers, you can connect, or hey, host, you can connect to two containers of this image on this port, okay? So back to the Nginx example where we routed to port 80. So the Nginx Docker file is going to say expose 80. So I'm exposing 4200. Last thing I want to do is I want to specify the process that my container should start with. Okay, now there's a couple ways of doing it. I can just not say anything here, and as my final argument of the docker run command, I can say, okay, bash or node serve. I can give it whatever command I want. But it's best practice to put something inside your Docker file so people know, okay, hey, this is what the image is for. There's two ways of specifying it inside of your Docker file. So you can use the cmd command, and then we'll just give it an array of strings. So the command I'm going to do is yarn serve. Okay, so this is one way of doing it. Now again, depending on your use case, you may or may not want to use cmd, because this can be overwritten, right? So if this is how I build my image, then when I run a container based on this image, I can, after the image name, I can say bash. Okay, then this will be overwritten, and my container will just simply start with the bash process running, and I'll get a shell for that, rather than actually serving the application. But I want to serve the application. So to be
you're saying only one command can run at a time, right?
Yes, only one process can be started. I mean, you can go inside of your container once you start it and like start additional processes, or this process itself could be responsible for starting other processes, okay? But we only want to start the container with just one process. And ideally, you're not going to have 100 million processes running inside your container, because then kind of defeats the purpose of being efficient. So a little more, I guess, stable way of doing this is we'll use the entry point command. Don't want that. So the entry point command can still be overwritten, but it's a little more like, it's just a little more of a messy command. And typically you don't override the entry point command. So the point of having entry point rather than CMD is to say, okay, hey, this is the purpose of this image. This is what you should use the image for. If you want to do something else that's not yarn serve with this image, you should just go create your own image. And in this case, if I pass additional arguments after my docker run command, those will be given as arguments to my entry point command. If that makes sense. All right, so does everyone have this Docker file?
When you wrote run yarn install,
Yeah.
Yarn already installed is already installed in the Node image viewport.
Great question, yes. So Node images, at least recent versions, have npm and yarn, and I think something else already installed. So that's super convenient. Good question. All right, so as you can see, like including white space, this is only 20 lines long. So Docker files are not complex. To write super efficient, like super performant images, you know, you might have maybe a little slightly nasty looking Docker file, but Docker files, you know, usually aren't super long. So it's pretty easy to get the basics. So with this Docker file, we're gonna come over here to our command line, and we're gonna say, we're just gonna repeat the last command we gave, which was docker run -it. And you can prefix it with whatever you want. We'll call it Bob is cool. And again, we'll tag it as deli. Oh, whoops, Docker build. All right, Docker build. So again, it's got to send the build context.
So is build context the file size says is something to do with Docker event size? Or
No, so that's a great question. So the question was, in case you didn't hear it, does the build context, so 292 megabytes, does that have anything to do with the size of the image? It does not. 292 megabytes, that's the size of all the files and directories in my current working directory. Once this finishes building, I can look at the size of all my images. So this step might take a little bit long.
But your current directory size isn't 300 MB, is that right?
292
You have
megabytes.
already installed packages inside.
Yeah.
Okay.
Yeah. So it's done. There we go. Awesome. All right, it's finished. So it's all done. We ended up with a total of 13 layers. Now, since it was asked, we can say docker image ls, and that'll give us a list of all of our images. So I have way too many images. So Bob is cool right here is 1.2 gigabytes. That's stupid. So there are some things we can do to make this better, and a lot of that has to do with the base image that I start with. So we'll look at some ways that we can make this smaller, but also these days, like running JavaScript applications it's just so many dang dependencies, right? So that's just part of the problem. With that, let's see if this works. So we can say docker container run -it. We'll publish, so I'll just use a shorthand notation, which is just P. I'll say 4200, I'll map network traffic from 4200 to 4200, and then we will use Hayden BR, Bob is cool, deli. So I'm gonna go ahead and start this. Yeah, so it says something is already running. That is weird. Let's see. All right, I'll just do a different port. I'll use port 8135 because I like that number. Awesome. Okay, there we go. So now we're seeing the output from my container. It's building. It's doing all the Webpack magic under the hood. Awesome. So it worked. So I should be able to go over here. Fingers crossed. 8135. Yeah. All right, there's Bob is cool. That's right. This is the coolest application ever. Okay, actually just glorified hello world. So that worked. So last couple things I want to look at for images is, as I mentioned, because we have this layering, when I go to rebuild an image, if it's already built the layers, then it doesn't rebuild them. It just kind of runs through and says, hey, I'm using the cache layers, you're done. So if I want to just go ahead and do a quick rebuild, I'll say deli version, I'll say deli is cool. We all like deli, don't we? When I build it this time, okay, it's going to resend the build context. But look how quick the build was that time, right? Nothing had changed. So if we look back over at the code, as it goes through, it sees, okay, has anything changed, okay? If nothing's changed, it'll just reuse the existing image. Now, if I make a change, for example, for, let's do this. I'm gonna go in here and just change something in the source directory. I'll just change something in here. And let's see. Color should be red. Be nice looking at. So now I changed something in the source directory, which was, let's see if I can get my Docker file back, which is on this level. So what we're going to see, if I now go ahead and rebuild, what's going to happen is it'll use all the cache layers up until here, and then it'll have to rebuild these lower layers. But these last three layers are super quick, so it's not really a huge deal. So if I go ahead and do this, I just rebuilt. Awesome. So if we look at steps 10 to 1, it just says, okay, using cache. It didn't have to rebuild those. If I look at 11 through the rest, okay, it had to recreate that layer from steps 11 through 13. Now, so that means that if anything changes in my package.json, then that install step was the largest part of the build there. So then that's going to require a little more time to rebuild the image if something in package.json changes, right? So if I go to, my neck is going to be sore by the end of today. If I just add some, I'll just say, I'll add something here just for kicks. If I just add anything to my package.json, even if it has nothing to do with my dependencies, when I go back, oh geez, I'm lost. Okay, here we go. If I go back over here and rebuild, and I won't make you sit through the whole build this time. Awesome, so it goes through and it sees, okay. Yeah, so it could use cache up until this point, but now package.json is different than what it used to be. So it had to rebuild from that point. And then once it has to rebuild one layer, all the rest of the image layers also have to be rebuilt. So again, we'll have to install all that. I'm not going to wait for that though, because we have more important things to do. All right, any questions about images? Yes, sir. So the question is, does the entry point command, does it have any significance of when the... No. So it does nothing. So the entry point, whether you use entry point or CMD, that doesn't actually do anything until you start a container based on that image. Yeah. Does that make sense? Does that answer your question?
Yeah.
Okay.
So what about exposing the ports here? So
Yeah.
we can only use the port in the mapping parts that you told us?
Yeah, so in this case, it's a good question. So in this case, I exposed 4200. So in that case, I can only publish network traffic from the host to port 4200 inside of the container. Just for curiosity, I'm not actually sure what would happen if I try something besides 4200. Let's try this and see what it does. Okay, yeah. So in that case, I can still specify a different port inside my container here. So it'll make the container for me just fine. But I won't be able to get any data. I won't be able to interact with my container from the outside. Yeah.
So what about if I have a Ubuntu image here,
Yeah.
and I hosted a Python server, let's say Node server, at
Yeah.
any random port, and then I mapped it, the port, mapped it to the host. Would that work without exposing the port?
You would have to expose something. If you don't expose anything, then yeah, you won't be able to get inside the container.
Okay, I think I just disabled the expose string
Mm-hmm.
in the Docker file and it works.
Oh, it does? Huh.
Because you're doing just P port, you're mapping with 4200, 4200, right?
Yeah.
It's picking it from there.
So you said inside.
So that's just a hint for.
So you didn't have this right here?
Okay, this is a guideline here.
Okay, yeah.
What would happen if you remove the port mapping?
What's that?
If you remove the port mapping but have the exposed part in the Docker file?
Yeah, if you remove the port mapping, so if I do this right here without, we will actually see what happens. So yeah, if I just get rid of port publishing, then I won't be able to get inside of my container. Like again, inside the container, the process inside the container will be exposing or will be listening on port 4200, but I won't have any way of getting network traffic from the host inside the container. Yeah. Okay. Yes, sir.
How do you make sure that your container is always running and monitoring of the container?
Yeah. So I guess your concern would be like more for like production use case.
Yes.
Yeah, I mean, so that's a little bit beyond today. So like there are like what is called container orchestration tools that kind of do all that for you. They kind of collect the logs for you. They make sure you always have a specified number of containers running, but that's production, whole different ballgame. Yeah. Break for lunch? Okay. Guess this is trouble having too many examples. Can I show one more example? Okay. So I did want to look at volumes, which is where you can pretty much plug in volumes, or directories from the host to the containers. We'll actually see some of that later on, so we'll skip those examples for now since we'll already see it. Just for fun, I want to do something a little bit crazy. So I mentioned earlier, so we're just going to take a quick look under the hood of kind of experience a little bit more of how Docker works under the hood, and then we'll call it a break. All right, so I just copied this command right here. This command works on Docker for Mac and Docker for Windows. I don't know if this will work on Docker Toolbox. So what I'm going to do with this, and I use this fairly often when I'm just like developing or like debugging stuff. What this does is it creates a container that gives me access to that Linux VM that's running. So the true host is that Linux VM that's running as part of Docker for Mac. And so when I run this, that'll give me a container inside of that Linux host. So I have this aliased as, I have this aliased as Docker host. And oh dang it, crap, cannot see that very well. So I'll go to cd, let's see, lib, var, var lib docker. Let's see, actually I want to go back. Yes, sir.
Can you explain the privileged string that you used?
I'm gonna be honest. Like I don't even know what this does. I just saw it. I just saw this. I found this on the internet somewhere and it worked. So, yeah.
Okay.
I'm not gonna make up some BS.
What about the PID plan?
Yeah, same thing. Yeah, I didn't actually bother looking into how it works, but maybe you can do that and you can send me an email and explain it to me. All right. So I'm inside here. I'm gonna actually open up a new tab. Oh dang it, that's awful. Make that huge. I want to run this docker inspect command. So I'm going to say docker image inspect. And I'm going to inspect that image we just built for Bob is Cool. Deli. All right, so this gives me like a bunch of metadata for my image. So what I can do with this is it can actually show me, okay, all of the, I can actually use this to see which directories are being used as a part of this union file system that are mashed together to create my image. So this might not look exactly the same because different versions of Docker have use a different storage driver under the hood. So I'm using overlay here, but right here, this part of the output graph driver, data, then lower directory, this is all of the directories that are used to make up my image. So I can copy this file path. Let's see. Let me go back over here to my special host container. And I'll just say, I'm going to ls all the stuff inside there. So if we see, you can't really see the output so great, but what that did was, okay, in that case, that layer of the image has all these directories in it already. I can go back to another layer. This would be really easy if I could see my cursor. Let's look at this one and see what's inside there. ls, that one. So in that case, okay, this is cool. So in this layer, all I have is this one directory. I created this directory. And actually, let's see if there's anything inside of that. So we'll go inside of OPT. Okay, we have app there. We can look at the app. Okay, it's nothing. So that layer was probably just for that one command that said, okay, run make directory opt/app. What you can do here, I find it really fun just to like jump on, get this Docker host container, and just look under the hood and see like, how is Docker, like what is it actually doing? How is it working? It's useful for debugging and just for exploring and experimentation. Actually, all right, just one more example, then lunch. Is that okay? Okay, it'll be quick, I want to demonstrate, so I mentioned previously, containers are built on what's called control groups or C groups, which limit the amount of resources that a container can use. Okay, now that is very significant because maybe you have a potentially deadly process running. Okay, if it's insulated inside of a container that has limits placed on it, then you're safe, right? So to demonstrate this, all right, I'm going to say docker run -it. I am going to limit it to only have 64 megabytes of memory. Memory swap, 64 megabytes. And then I want an Ubuntu container. All right. Actually, let me make sure. I'm going to need another tab for this. All right, cool. All right. So I'm inside of this container that's been limited to only been able to use 64 megabytes of memory. And I can also, over here, I'm going to say docker container ls. This is the one I just created. So I'm going to say docker stats and then container ID. All right, so that just kind of gives me, I can look here and see, the resource usage. So I'm going to go back. I'm going to do something really naughty. I don't suggest don't do this part of the demo because I'm not going to take responsibility if something bad happens on your computer. So does anyone know what a fork bomb is? Yeah. So I can fork bomb my container. Okay. Has anyone ever done this on their own computer?
No.
I don't recommend it, but I have. You got to find out what happens, right? But if you do it, don't blame me. Okay, so I'm going to run this, and if you don't know what this is, this pretty much eats up all my resources until my computer crashes. So I'm going to do that, and it's all well and good. So I can see what's happening over here, and then eventually it'll hit a certain point, and it'll die. So my memory usage is up. Where is my? There it is. So here's the memory usage. Yeah. So it's starting to hit its limit. And at some point, let's see. Yeah, so the container itself is frozen. The process it's running. Yeah. Cool. So in this case, like my computer is safe from that fork bomb, and so only the container that had limited allowed resources is being affected. So yeah, all right, so this is the last example. We'll break for lunch. When we come back, we'll containerize our JavaScript development environment. So with that, let's get into some more JavaScript specific stuff. So we're gonna go ahead and Dockerize our dev environment. So many times, I don't know about you, but my experience with starting up with a new JavaScript project, a lot of times this is how it starts off, right? Like, you look at the README and it says, okay, just npm install and then run some command and you're good. And then like it doesn't work, right? As JavaScript developers, we probably spend more time than we would like fighting with our package manager. And that's not limited to only JavaScript. That's pretty much any language you work with. You're gonna have some kind of package manager and you're gonna have to fight with it at some point. So Docker can help us, or can kind of help ease that problem a little bit. And the problem is that dependencies are hard. Okay, dependencies are just a pain to manage because I think we have a lot more dependencies than we realize. On one level, we have global dependencies. Okay, so our operating system. Okay, whatever OS we have, our running our application for development is dependent on the OS we have. Our C++ compiler, more often than we probably realize, a lot of our Node packages actually come as like C++ libraries and we have to build those binaries when npm installs them. And so if you don't have the right C++ compiler, then some of those dependencies won't install properly. Also, the global Node version on your machine is also a global dependency. The version of your package manager, whether that be npm or yarn, is a dependency, and then other CLI tools is also a dependency. And so one of the problems we have is that we end up with different projects requiring different versions of the same global resources. Managing that back and forth between different projects can be a real headache. There are some ways of solving, for example, the problem with nodes. So you have a node version manager. It's like a tool where you can use to very quickly switch the global version of Node you're running with. So there's that. But even so, that only fixes the problem with your global Node version. Also, a lot of times, whenever there's this new cool JavaScript CLI that someone comes out with on npm, everyone wants you to install globally their CLI. Okay? Even just forget Docker and containers for a second. We should really rarely be doing this. Okay? And this is an opinion of mine, so there's no absolute truth or very little absolute truth in programming, but this is a strong opinion that I have, is that we should really be careful about how often we're doing this, because we end up creating for ourselves more dependencies than we really should be depending on, and it's going to cause headaches. Regardless of if you learn nothing else from today, if you take away nothing about Docker, at least take away that, next time someone says npm i-g, just be a little bit careful before you do that. And then we also have project dependencies, right? Inside one project, right? If the project is, any longer than a month long, at one point in time, your dependencies, whether you use Angular or React, or on the back end you're using Express, or these major dependencies, they're going to be at different versions at different times. So if you need to switch back and forth between, what you're currently working on and then what's in production, those dependencies might be different. So that causes headache, and switching back and forth can be a real mess. And then sometimes certain packages require peer dependencies that you didn't always get, and so that can be a pain. And then maybe you've had this experience, or maybe you've done it to other people, but sometimes someone might add a new feature to the project, and adding that new feature required adding a new dependency, right? So they push the code, you get the code down, and you're like, what the heck? Like, it's broken, it's not working. And they said, oh, well, it works on my machine. And the problem is, like, they forget to tell you, oh, hey, I added this dependency in the package.json. You need to, like, npm install again when you get the code.
Probably because of this reason, Eddie Osmani said that it's always a good idea to include your npm packages also as a part of your code repository.
Yes, you can do that. We'll actually talk about that in a minute. That can cause problems sometimes too. So common solutions to the problem. I don't know if you've seen this. This is out on the internet somewhere. This is the npm please command. This is the, as it's been said, this is the missing command for npm. Like, let's say you install all the dependencies, doesn't work. I don't know, like, I've done this so many times. You just trash all the dependencies, reinstall, and you just pray it works. It usually doesn't work, but for some reason we just think that it helps. Another solution is maybe you get really desperate and you just back out and then you just completely nuke the repository you're working on and just clone it fresh. I've done that a few times. You shouldn't do that, but I've done it a few times. Yeah, so that happens. Another one is, as a gentleman had mentioned, sometimes maybe you want to add node modules. You want to check those into version control. I don't mean to call you up, but like, I disagree with that. Reason being is because, like we mentioned, right? Like, some of these dependencies are just binaries built from C++ code, right? So like, if you check in binaries that were built for Linux, well then when you go to run that on a Windows machine, it's not going to work. It's like definitely not going to work. So again, like, that only works if you know the person's environment on their machine is exactly the same as yours. And it just creates like a giant, like, then your repositories become giant.
This will also increase your Git repo size hugely because these modules are like too much to spread out.
It will, yeah. Which isn't, just like having a big Git repository isn't the end of the world, right? Because like, whether you're getting your dependencies from GitHub, because they're checked in, or you're installing them from npm, it's going to take time to get all that. So it's not a huge deal that you have a big repository.
Sorry, quick question on that. So basically, the end product is always a JavaScript file, even if it is compiled from C++ environment, right? Yeah.
Not always, because sometimes JavaScript files will call binaries that were built from C++ code, right? Okay. So you can call C++ add-ons from JavaScript. It's like, for example, does anyone use Sass for their style sheets? Yeah, so like Node Sass, when you install that depends on libsass, which is written in C++. So when you install Node Sass, that has to be built. Yeah. Other common solutions is like, maybe we'll just like start updating global versions of Node or whatever else, and that's dangerous. Or then maybe if it's not something you're doing for work, you might just give up on the project. And that's unfortunate. That's not how we want to end. Another solution that's actually come out recently is, instead of using like a Node version manager, you can actually install Node you can just install the Node binaries itself. And that'll end up in your Node modules. But then again, that only solves the problem of, global Node version. So that could work. Honestly, I'm not super comfortable with doing this. I'm not going to say not do it. Like, some people do it and it works fine. I just don't want to do it because, again, you end up with like a humongous, your Node modules become even larger. And again, it only solves one part of the problem. Now, so we're going to use Docker to help solve this problem. But you might be thinking, all right, so like, isn't Docker just another dependency that we're adding? But really what we end up doing is, if we can build image to create containers for our development environment that contains our dependencies, in that case, it's almost like we kind of like flatten our dependency management, right? Instead of having to worry about all these different versions, like, we just have to make sure, okay, that my Node modules still work in this containerized environment, but down the road, like, it really helps us, it really kind of takes the burden off of us of having to always keep up with our Node modules, because Docker will do it for us. So yeah, and so you really it really kind of turns into managing one dependency versus managing 50. So it's a trade-off. And it's also important to note that, like what I'm about to show you guys with Docker, like it's only one solution to this problem of, the headache that we get from managing dependencies. Right? Again, like there's very little absolute truth in programming, right? So what I'm going to show you, like this, I really like this solution, works for me. It might work for you, and that might not work for some of you. Or maybe you want to take what I do and kind of adjust it to fit your needs. That's okay. But so if you don't like this solution, no worries. You won't hurt my feelings. But it is important to note that unlike most everything else in JavaScript land, containers aren't just a fad, right? Like in JavaScript, we have lots of fads, and like every 6 months, there's a new cool thing.
Framework.
Yeah, there's a new framework. Containers, the containerization technology isn't something that's just showing up and will go away soon. Containers, whether it's Docker or some other container platform, they're here and they're here to stay. So using them to depending on them in our development is not a bad thing, because they're going to be around for a long time. Just disclaimer, it's not the only way. And to be, I guess, semantically correct, it doesn't really solve the problem. It kind of prevents the problem for us. So what I'm about to show you is we'll be able to, instead of having to keep up with our node modules ourselves and always worry about the versions, Docker will handle that for us. So what we're going to do is we're actually going to, actually this is the second example. So, so if you go to, I'll just go up there. At the very beginning, I gave you 2 links. One was Bob is cool. The other is New Year's resolutions. So if you just go to github.com/aidenbr/New Year's resolutions. So if you just go here, just go ahead and clone this repository, and then I have it over here. Let's see. Yeah. All right. So I have it over here. And when you clone this repository, go ahead and check out this branch right here. That's what we're going to work on for today. So what we're going to do is we're actually going to build an image that contains the node modules pre-installed for us, so that we can very quickly get up and running with this project. So what we're going to do is we're actually going to at the same time look at a few best practices for writing Docker files and building images. So we're going to start off stupid simple with our Docker file, and then over the period of the second portion, we're going to make it better and better. All right. So any questions before we get started? No? All good? Okay, cool. All right. So we'll get started. Don't need this anymore. Okay, so over here, I am going to open up this blank Docker file. All right, so we are going to start off just really stupid simple. Okay, so what we're going to do is we're going to start off with our from, and like before, we're going to do node 8.9.4, and then, oh goodness. Yeah.
Do you have a plugin for VS Code for Docker?
Yes. If you search Docker, it's the first one that comes up. Yeah. It's pretty cool. All right. So after from, I'm going to set an environment variable. My node environment I will set to development. Now I know that this node image is based on a Debian image. So at work, when we use this, we actually use an FTP server because we actually build our code that we use in production in these containers, and then FTP that code to the production server. So we're kind of halfway in between Docker for production and Docker for development. But anyway, so our container needs to have that FTP server. So we'll use apt-get update and then apt-get install ncftp. All right, that'll be our FTP server. And again, there might be other command line tools you might need to install at the beginning. And now we're going to start putting stuff in from our build context. So again, like before, I'm going to create my opt/app directory. I'm going to set that as my working directory. And then what I'm going to do next is I'm just going to copy everything from my build context into my image. That's actually not a good thing to do. So we're doing this a little naively to begin with, and then we'll install. Because like generally, like when you start off like Dockerizing your applications, which Dockerizing means, okay, build an image in which to run your applications in containers. When you start off, right, like you don't want to try to get it perfect at the beginning. You just want to get it running at first. And so that's what we're doing here. We're just copying anything and everything inside of our container. So this might be how you want to start off when you're doing this on your own, but you don't want to end this way. But it's a good starting point. So then we'll install the New Year's resolutions example app. It's like a glorified to-do app. It's built on the Ionic framework. Is anyone familiar with Ionic? Yeah, so it's like another like high-level front-end framework that's built on top of Angular. So dependencies on dependencies on dependencies. And for that dev server, we actually need to expose 3 ports, 8100, 35729, 53073. Okay? Now, with only these few lines, I could build this image, okay? And then I could start running containers based on this image. It's not a great solution. It's not even a good solution, but it's a starting point, okay? There's a lot of things I didn't do, and especially like I didn't even specify any like command or entry point at the end, but you could pass that in at the point, at runtime in your CLI, okay? So if I built this image, I could run a container like this. So Docker run New Year's resolutions, and then I could just say, I can say Ionic, or I could say yarn serve, and then that'll tell, okay, hey, when you start up the container, start it with this yarn serve process. But like I said, best practices, typically we want to include something in here. So we'll go ahead and include an entry point, okay? And we will make that yarn serve, double quotes, yarn serve. All right, cool. All right, so it's a little bit better because we had an entry point now. So now we're a little more explicitly saying, okay, hey, this is the purpose of these containers. Any container that's created based on this image, the purpose is to run this process, which will serve my application. Okay, so that's good. So we're being a little more clear about what we're doing. Now, if you remember back to the Dockerfile example we did before the break, we saw in the command line where it would pass the build context to the Docker daemon, okay? And so it's just saying, okay, hey, here's all of my current working directory. You can read it. And it took a little bit of time, okay? It was having to pass 200 and some megabytes to the Docker daemon. And so that took some time. Additionally, there might be things in my current working directory that I never, ever, ever want to end up in my images, right? So in this case, I'm adding everything into the image, even my node modules, which I definitely don't want to do. So very similar to how we have a git ignore, you can have a Docker ignore. So what Docker ignore does is it filters directories and files from the build context, right? So if I just add node modules and my git directory, like even if I just add these two, when it doesn't need to pass these two directories to the Docker daemon as part of the build context, right? So the more you add to this right here, 2 benefits. 1, it makes your images much safer. Secondly, the start of building your images is much quicker because it's not having to pass these extra things to the daemon. So
downside is that the build will take more time.
What's that?
The downside is the build will take more time.
Does it take more time?
It
shouldn't take more time.
The deployment, build deployment will take more time.
Why do you say that?
Because node modules are not part of that. So are you saying that most of the node modules are would only get installed first time and it would only be the updates that would run?
Right, yeah. So yeah, you're right. So by me not putting node modules inside my image, Yeah, I do have to install dependencies. I have to install my node modules inside the image.
So is it like one, the first time it gets installed and next time it updates, or is it a fresh install?
Yeah, so that's a good question. So if I build, let's say, okay, I build my image for the first time, yeah, definitely I'm gonna have to install all my node modules. The next time I wanna rebuild that image, if my package.json hasn't changed, or to be more correct, if the line, any lines previous to my install line in my Docker file hasn't changed, right? So this is where I'm installing, right? If none of this has changed, then when it gets to here, it won't have to reinstall my node modules.
No, the question is basically if there is a new update in the yarn, like in the node, in one of the npm packages, node modules, would it basically get installed afresh every time we create an image and ship it?
Yes. So yeah, if there's any change in your in any of your node modules, then yeah, it will rebuild.
How do you know that package has changed? Let's say I have added package.json as taking the latest of any package. Right. When it get to run yarn, it will not know that the package version has changed on the cloud. According to it, the file is
right. So it's checking what's inside of package.json, right? Because
I think they are asking specifically about our package and not the package file.
So we didn't actually change the package.json file, but the module that we're referring got changed in the cloud.
yeah.
So we will not be getting the latest packages now.
No, that's fine because your package.json package.json specifies which version, right? Now that version might allow the most recent and it might not. So yeah. But like for production use case, right? Like you'd want to be as specific as possible in your package.json, so that way you know always exactly what you're getting, right?
For production, you generally fix your dependencies and increment it manually. So
Yeah.
that's the use case.
Yeah.
So
You don't always fetch the latest
So
one.
in case the question was that in case we have specific dependencies in our package file and we create a new dependency, right?
Mm-hmm.
Would only the dependency get added to that package, or would it be the complete package payload every time?
Okay, I understand your question. Yes, it will be a whole reinstall of everything, not just that one. So it's a trade-off, right? So yeah. But we will look at a way that we can minify, or reduce the amount of times that we have to do that complete reinstall of everything. But sometimes you want to have even if you only add one package, sometimes you might want to do a fresh reinstall of everything because that package you added, maybe it has a different peer dependency. So sometimes I don't know, typically when I'm working on my machine locally, not even inside Docker, I'll just reinstall everything anyways. So yeah, it's a drawback, but most everything is trade-offs. But if you use Yarn, it's a little bit quicker. So yeah. All right, so this is our very naive Docker file. Now, we improved this by, saying, well, when I just add everything, now it's not including node modules, right? So now when I install, I know I'll get the node modules that are appropriate for for the environment that I'm working in, which happens to be Debian. Now, but still, just looking at this isn't very specific, okay? Just saying, hey, put it all in there, right? Because then, maybe you write this, or maybe I write this, and I know what this is doing, because I know what I put in the Docker ignore file, right? But, if you come along and you try to figure out, okay, what this is doing, you're gonna have to go back and forth between two different files to figure out, okay, what actually ends up inside the image, okay? It's better because, we're working on teams, so we want to be able to help out our fellow developers. So it's better to be as specific as possible inside our Docker files. So a better way to do this is we could say, maybe I want to, copy package.json. So I want to get that first. And then after I install, I'll get everything else. Let's see. All right. Now, also, the problem with what we did previously was I was adding my source files and all my files at the same time as I was adding package.json. I don't want to do that because because remember, if this line changes up here, then this line has to be rerun, right? Well, that means if I add the source and my package.json in the same line, if there's any change in my source code, then I'll automatically have to reinstall. But that's unnecessary, right? Because I only want to reinstall my node modules only if the dependencies in my package.json change. Okay, so that's why we can split out like this. Additionally, we can make this a little better by being more specific. So in this case, I'm just gonna copy and paste, I'm sorry. Because you don't want to watch me type all this. You can type it if you want. I'm going to be more explicit about what I'm putting inside. And you can use copy or add here. I should have used copy, but no big deal. So we can be more explicit. So now there's no you don't have to search through Docker in order to figure out what's going in the Docker image. Ignore file is kind of there for backup. You don't have to reference it. You just look at the Docker file to know, okay, what went inside the image. Now, so this is even better. But we can make this even better still. So one of the examples we have to skip over is that you can actually plug, directories and files from the host, you can actually plug those in to the container when you start the container at runtime, okay? So, in that case, it's just much easier. These files might change, which would cause a rebuild of the image, right? But if I can just plug them in at runtime when I start development, then maybe I don't actually even want any of these. So maybe I just want to have my package.json, install dependencies, everything else. I'll just plug it in when I start my container. So actually, our Docker file just got even smaller. Now,
I missed your point. You remove the files so that.
Yeah. So I'll give you a quick example, right? So these are all just config files, right? And source, right? So the image really isn't dependent on these, right? All I want to have inside of my image is just my node modules, and that's pretty much it. Because these really, I don't want these to impact how I build my image, right? If these are just some build scripts, this is just my webpack config. These are only concerned with running the application. So if I can plug them into the container at runtime, then I'll just leave them out, okay? Now this is typically how you want to do it. You want to remove these if you're building a development container. If you're building a production container, right, you just want to have the container and run it. So with a production container, I would leave these in. I would also put my source in a production container. With a development container, you don't want to do that because these files that are gonna change as you develop, they don't actually impact the environment necessarily. You want to just be able to very quickly and dynamically plug those into your container and not have to worry about rebuilding a container or rebuilding the image every single time. Yeah. Now, I want to ask you guys a question. So we said that if anything on this line changes, then running yarn install is going to have to be rerun as well. But I only want to reinstall my node modules only when necessary, right? So if we take a look at what a typical package.json might look like, right? So this is what we're putting in. If anything in this file changes, I've got to reinstall. So now what problems do you think might that cause? If I'm using this file itself to install dependencies, what problems do you think we might run into? Or I guess maybe not problems, but inefficiencies.
It should update only when any dependency will change.
Yeah.
I think you have
Or
to use
their
the
dependencies.
log file.
But yeah, so there's also we only wanted to reinstall if these change, right? If I've got some scripts up here that change, or some metadata up here that changes about the project, I don't want to have to reinstall my Node modules. So in that case, we're going to do something a little bit tricky, and I'll explain where this comes from in a bit. But I'm actually going to say, okay, you know what? I'm going to copy in Docker package.json and as my package.json, right? So this right here is actually a file that I'm auto-generating whenever I update the version number. So if you look over here, and we go inside of Docker, so it's just everything's stripped out of the package.json except for the dependencies themselves. All right. I'll go over a little bit in a bit where that comes from exactly. So that again is going to save us from having to rebuild unnecessarily. So I can change anything I want to in my package.json file. As long as dependencies or my dev dependencies don't change, I'm still good. I can still use that image layer that was built previously, and I can save myself a whole lot of time. Now, we also saw last time that when we built the image for the Bob is Cool app, the image was humongous. It was like 1.2 gigabytes. Part of that is our Node modules, but some of that is also, actually a lot of that is actually the base image that we start from. So I'm using right here Node 8.9.4 is the base image. This image itself is pretty big. I think it's around like 600 megabytes, if not more. Actually, no, it's actually more like 800. You can do Docker image ls in the command line, and that'll show you all the images you have, and you can see file size. We did that last portion. So this is actually a pretty big image to start off with. Now, by looking at Docker Hub and seeing all the different tags, I know that I've got some options. Node has given me some different options to use for base images. So one thing I could do is the Node repository has what's called slim images. So these images are a little more efficient in file size. So I could do that, and probably everything else would still work. I could even go actually more extreme, and for every version, it also has an Alpine image. So this is an image based on Alpine Linux, which, if you're familiar with, is like a super scaled down Linux distribution, okay? So, yes sir, you have questions?
I think this is an operating system, right?
Alpine is a Linux distribution.
Right, so you have to have the operating system in the image. Not trying to without it.
Yeah, I mean, well, that's what we had before, right? So like before, when we just did Node, it was Debian. In this case, it's Alpine, right? But still, it's not an operating system that I have in my image. It's a Linux-based image, right? So like it could have been Ubuntu, it could be Debian. You could just run like an Alpine image or an Alpine container itself. And if you see, they're not full-fledged operating systems, right? They are images that are based off of those or kind of like inspired by the operating systems themselves, but they're not full-fledged operating systems. They're virtual operating systems that are much more scaled down than the actual real thing. Yeah, does that make sense? So if I use Alpine actually uses a different package manager. So I'll just say it uses APK. So we'll say APK update, and then we will APK add this dependency. All right. Now I can get even a little more tricky with my Docker file. So notice I have these 3 run commands in a row. Okay. Now it's fine to have these 3 run commands, but that ends up giving me 3 different image layers. Okay, which isn't awful, but it's a little more overhead than necessary. If I combine all these commands into one run command, then my resulting image becomes even a little more efficient. So what I can do is I will just say run APK update, and then I'll start a new line, and I'll then do APK get ncftp. Oh, also I need to create my directory. So let me do that. Victor opt/app. All right, there we go. So I can do this. So again, my resulting image is going to be slightly smaller since I combined those 3 run commands into just one run command. I can get even a little more crazy, and I can, sorry, actually that should be add, not get. Yeah, so I can get even a little more crazy. I can say, hey, you know what? Don't cache any of this when you install it. And I could, if I wanted to be super OCD, could even specify a version number for this one, which is a good thing to do. All right. And then lastly, you might see some people, like if you look at some other Docker files, you might see some people like after they like install dependencies, they might go back and like remove some directories. So we can even remove these few directories, even though I said not to cache. Usually it ends up with a few things in this directory, right? So again, this one line ends up installing replaced those 3 lines, and the image size comes out a little bit smaller. Now, earlier this guy mentioned, he's like, well, you know what? If you have a bunch of run commands, or a bunch of calls all packed into one run command, if you just change one of those, then you've got to redo the whole command. You've got to redo everything in the run command. So again, this is a trade-off, right? So you end up with a little bit better file size, but it's a little more fragile to image rebuilds, right? So, but again, like you would do this with, a little more stable things, right? So these things up here, like I'm not gonna hardly ever have to change these. So I'm pretty safe doing this. You would never want to combine, or hardly ever want to combine yarn with a command. I will do this though. So I can say yarn cache clean. That's pretty safe to combine with the yarn install command because, this kind of follows naturally after fresh install dependencies. So if I clean the yarn cache again, I won't have those extra dependencies cached in my container environment. I'll have only those installed for inside the directory for running the application. That's it. So at this point, we have a pretty, this is like a pretty good Docker file. The one, so we have a very similar setup for one of our projects at work, and it looks kind of something like this. If we want to make things even cooler, we could come to our Docker ignore. And if you notice, all we're adding inside of our Docker file, let's see, Docker file. The only thing we're adding from the build context from our current working directory on our local machine is just the package.json, right? So that means I can add everything else to the Docker ignore file. So I'll copy this and go back over to Docker ignore. So in this case, it's filtering everything except for this one directory. And so in that first step of building an image, when the client is passing the build context to the daemon, it's super quick because it's less than a megabyte. So again, that first step is much, much quicker for us. So at this point, I could go ahead and build this image. I'm actually going to go ahead and switch back to, so at this point, I'm switched back. You can go ahead and rebuild, or you can go ahead and build the image for what we just put together. But if you switch over to the dev branch, it has the Docker file already written out for you. So now, I should mention where the Docker / package.json, I should mention where that came from, right here. So what we do with this setup is we have a script that rebuilds the image every time we bump the version, whether it's a major, minor, or patch version change. So what we do is we end up with almost like version environments, right? So I'll show you the script. It's in scripts, bump.js. So pretty much all it does is just goes through and updates the version number and package.json. If any other file mentions or refers to that version number, it'll update that. Then we commit and tag and push those to our Git repository. And then here we rebuild that image and we tag the image each time with the new version that we just updated our package.json to. And then lastly, then we push everything. And so this process is run every single time we run a bump command. If you look at the package.json, it's just like npm or yarn run major, yarn, minor, yarn patch. They're in the script section of the package.json. So that's what, as you can, I mean, this is JavaScript, so we all know JavaScript here. You can look at this more on your own time if you want. Nothing new. So at this point, I said, okay, we've got to plug in all the volumes, all of the, all of the source files that I didn't include in my Docker file. So I've got to be able to plug those into the container at runtime. Oh, here it is. Sorry, it's back on the Docker for JS devs branch. So to actually run a container based on this really optimized image, we have to run this heinous command, okay? So you're definitely not typing this out every single time you want to run a container. So one option that we have is we can script this out. Just put it in a shell file. But even still, that only does us but so much good. So what we can do is, I'm not going to talk about it today, but there's this really cool tool called Docker Compose. Okay, when you install Docker, Docker Compose came with it. So Docker Compose it's a development tool. It's suggested that you actually don't use it in production, but it's used to kind of abstract away these nasty kind of commands. So kind of like it's like a configuration file for all this crap here. So we just look at it real quickly. It's saying, you know what? I want you to run a container based on this image, and then plug in all of this stuff from the host machine. And then this is the same as the publish command we did before when we did Docker container run. And then actually right here, this allows me to pass in environment variables from the current shell that I'm working in into the Docker container itself. So you can run it from that script I showed you, or you can actually run it from here with Docker Compose. So let me go back to git checkout dev. All right, at this point, so at this point, let's check and see if it works. All right, so just for fun, let me actually go ahead and remove my node modules just to prove that this works. So I'm going to say Docker compose up. And this will use that Docker compose file I showed you and then start the container or containers specified in that config file. So I'm just going to run this and it's creating that container. It's building the code. So far it seems to be working. But so the value of this is, right, just using this image, I can get up and running really quickly without even installing anything. I'll just pull the image, that's it. All right, so it's finished. Let's go over here and see if it works. So we are on localhost 8100. Go there. And it works. All right, so we were able to use that container without even having any node modules installed locally to run and develop our app. Now, the cool thing about this is remember, we plugged in the source from that was living on the host machine, right? That means that the container itself is looking at the exact code that I have on my machine. So if I am, let's say I go in here, Docker is fun. This is like this annoying pop-up that comes at the beginning of the app. So I'll save that. If we look, the container saw the change that happened on the host because I gave the container access to those files. When I come over here, it reloaded on itself. So that's pretty dang cool, if you ask me. Yeah. All right.
Totally magic.
It's magic. It is magic. All right. So at this point, let's see. All right. I need a volunteer. So this is only the tip of the iceberg. So what is there left for us to learn? The next thing would be, okay, so take this process that we just did here and see if you can get this to work for one of your own projects, you know? Or maybe just, you know, one of your example apps, maybe not even a production app that actually has users. Just, you know, see if you can get this working, see if you can Dockerize one of your own, personal applications. So see if you can do it yourself. Next, it'd be great to learn about Docker Compose. So Docker Compose is an awesome tool, but you have to understand everything that we talked about today to be able to use Docker Compose. So now that we've kind of got a hold on some of the basics, like what's a container, what's an image, how all these things kind of work together. Next step would be, okay, use Docker Compose to actually run your containers for development. Next thing is container orchestration. So let's say you've got to the point where you're like a Docker container master, all of your local development is inside containers, and you're like, okay, you know what, I'm ready for production. So in that case, there's a couple tools you can use. So one is Docker Swarm, which is what we have here on the left, which is a way of being able to have like multiple containers of the same instance, running in production, right? Because if you have like a API, like a backend application running, you don't and it's like high usage, you're not going to want just like one small container to serve your clients. Like you're going to need a lot more than just one container. So Docker Swarm and Kubernetes, you may have heard of, are two different container orchestration tools. So Docker Swarm you get when you install Docker. Actually, pretty soon, Kubernetes will start shipping with Docker. If you've heard anything about Docker previously or containers and really didn't know much about it, you probably also heard about Kubernetes. So Kubernetes itself doesn't actually create any containers. It's a tool that says, okay, you know what? You implement these specifications, and then you can use Kubernetes for orchestrating and managing your containers for production, right? So most people use Docker containers when using Kubernetes for orchestration, but then there's also some other containerization platforms out there that can be used with Kubernetes as well. Actually, most of the Docker captains that I've heard from these days have started to recommend Kubernetes over Docker Swarm. I've used Swarm and had a few issues with it, and Kubernetes is next on my list. Lastly, just want to get some shout outs. So my boss, Nick, kind of let me some time back experiment with this kind of Dockerization setup to get it to a point where it was actually usable. Previous coworker, Shaw, he originally built the wonderful example app we looked at. These two guys I mentioned earlier, Nigel Poulton and Brett Fisher, are two pretty distinguished Docker captains that have produced a lot of great content on helping you learn Docker. And I got kind of like my starting point from these guys. Lastly, I want to thank John, guys, the local Richmond Docker captain. And he actually hooked me up with some t-shirts, which I'll give out in a few minutes. To everyone, thanks for coming.